Hello physicists, I'll give my year 10s this paper, so I'm going to make a start and have a look at question 1. Here we go. Okay, in the first question we've got a creature from Pedro's planet that, similar to bats, uses ultrasound to detect its prey. So it's going to send out an ultrasound signal, it's going to reflect off the prey and come back to it, and it's going to use that to kind of find its prey and catch it. We're asked though a question, a maths question really. What is the frequency of this ultrasound, given that the speed of sound in air is 330 and the wavelength is 11 millimeters? So as I always say, write down your information at the side. We have the velocity of the sound, 330. We have the wavelength, which is 11 millimeters. So what I'm going to do, let's convert that to get 0.011 meters. That way we're working in the same units. Yeah, 330 meters per second, so we need the wavelength to also be in meters, and the frequency is what we're trying to find out. We know that's going to be in hertz. Okay, so rearrange to make frequency the subject. It's going to be velocity over wavelength. 330 divided by 0.011 is going to give us 30,000 hertz. I'll stick that on the line to be sure. Now, if you had not done this conversion, and so you got the wrong answer there, you got 30 for example, you would still get 1 mark. Okay, but try and make sure you check your units and make your conversions as necessary. Okay, the pulse returns after 18 milliseconds. Don't get caught out by that. That's not meters per second, that's milliseconds. Calculate the distance to the prey. So this is a super common question when you've got ultrasound, the idea of a pulse, a signal going to something and then coming back. And so we're going to have to remember an important factor. But we're just going to start with velocity equals distance over time. And then we're going to change that because what we want is the distance. So distance equals velocity times time, and what we're trying to work out is that distance to the prey. So we know from the previous question, but let's just put that down here again. We know that the velocity is 330 meters per second, and we know the time for the pulse to return is 18 milliseconds. So again, let's convert that. 18 divided by 1000 is going to equal 0.018 seconds. So we're going to just put that into our calculation, and that's going to give us 5.94. Now, the easy thing to think is that we're done there. We've gone 5.94. We've worked out the distance, simple calculation. But of course, what we've got to remember is the signal has to go to the prey, reflect off the prey, and then come back. So in terms of the distance that's actually traveled, it's to the prey and back. So what do? We have to divide this number by 2 and get 2.97 or 3.0 is what I'm going to leave the answer as, 3.0 meters. Now, just to clarify, that's 3 meters that way, 3 meters back, which gave us our 6 meters there and back. So to 2 significant figures, 3.0. You would get full marks for that. I'm probably going to get bored of me repeating that, but unless it specifically says significant figures, but I always want to try and get you into good practice in using the right amount of significant figures. There were 2 in the data that we had, so we're leaving our answer to 2. All right, that was question 1. Hope it's useful.